All right, we're back for another exciting episode. Does everybody want to say hello to our friends at home? On the count of three, everybody say hello. 1, 2, 3. Oh, good. So beautiful. You guys make me feel warm and fuzzy. Guys, this concept of inverse, people, Jelani, hate. They see it as being hard. They see it as being difficult. They see all this weird notation. And guess what? It's actually very easy. Okay, but you really just got to pay attention to a couple of key factors. Okay, I want you to start off by highlighting these two statements, because these two statements at the very, very top are the most important thing. It says when we talk about the inverse of a function, the general idea is to switch the x and the y. Highlight that, star that, circle that. Don't cross that out. This is being silly. Let's try this again. Okay, and then I want you to also highlight that. Graphically, an inverse is a reflection in the line y equals x. Then I got a whole bunch of stuff down here. I'm going to come back to that. Okay, so hold on to this thought. We're coming back. All right, guys, here's what I got. On the graph below, I have the linear function y equals 2x minus 4. Do you see how it's labeled right here? Bang. Okay. Then I have the line y equals x. Everybody sees that. Okay, that's labeled. Bang. Okay. How can you quickly tell that 2x minus 4, this one right here, is a one-to-one function? Oh, good. I see two hands. I should see everybody's hands. This was from last unit. A function is one-to-one when it passes the horizontal and y and vertical, because I said it's a one-to-one function. Okay. It passes both the HLT and the VLT. Bang. Got it. Now it says to graph the inverse on the same grid. Guys, here's all I need you to do. Ready? Pick any 2 points that are on this line. Any 2 points that you want. I'll choose this one, and I'll choose, sure, this one. Okay? So Jelani said 2, 0. I chose this point here, which was 0, -4. Okay? Those are actually 2 good points to choose because they happen to be the x and y intercepts, right? So all I want to do, guys, all I want to do is that I know on the original graph, so on the original graph, I have these 2 points. I have the point 2, 0, and I have the point 0, -4, right? Yeah, I'm gonna alleviate all your fears right now about this being difficult. Ready? The value of 2 is what kind of a value? X. The value of 0 is what kind of a value? Y. All I want to do is create the inverse. So watch what I'm going to do. When I create the inverse, I use this notation. It's f raised to the -1 power. And here's what I know. I know that on that line are 2 new points. And what did I say and have you highlight right at the very, very beginning? The general idea when creating an inverse is to what? Switch the x and the y. So if 2, 0 is on the original function, what is on the inverse? 0, 2. And if 0, -4 is on the original function, what is on the inverse? -4, 0. And so if I plot those 2 points, I know 2 points that are on the inverse. So there's 1 point. There's the other point. I only need 2 points to create the equation of a line, right? Connect the dots. Try to connect the dots. And you get that line right there, okay? And we're going to label that line with f to the -1 of x. That's our notation for an inverse. What can be said about the graphs of 2x minus 4 and its inverse with respect to the line? Well, guys, isn't this yellow line and this black line reflections of one another in the line y equals x? Right? You can see it, right? It's a reflection. So the inverse is the reflection of the original function in y equals x. Oh, this is so fun. Now it says to find the equation of the inverse. Guys, what was the equation of the original function? It was y equals 2x minus 4. Right? Everybody agrees with that? That was the original function. Now, what is my rule for an inverse? Switch the x and y. Well, if I switch the x and the y, what does this become? X equals 2y minus 4, right? So you guys see how I just swapped them, right? I literally swapped them, okay? And now I'm going to solve for y. So if I solve for y, what do I need to do? Give me something to get y alone. Go ahead. Before that, add the 4, right? And then now what? Now divide by 2, right? And so I wind up getting x plus 4 divided by 2 equals y. Hey guys, real quickly, one more thing. If I wanted to change this y, what could I call this now? This is the what? This is what kind of a function? This is the inverse, right? That's the inverse of f of x. Do we agree? Because how did I get it? I swapped the x and the y. So what can I call this? I can call this f to the -1 of x. Okay, because that's another notation. That's another way to write that. Is that cool? You guys like that, right? Literally swapping x's and y's, okay? Guys, that concept, right? If you're following along, you're really paying attention. It's not a difficult concept at all, right? It says which of the following represents the equation? Well, of the inverse of this. So what do I need to do to find the inverse of this? Swap the x and the y, yeah. And then get y alone. So I wind up getting y equals x plus 20 all divided by 5. Is that one of my choices? Do I have a choice where everything's being divided by 5? No, but how could I rewrite this? Well, isn't this 1x over 5, which is 1/5 x? And how many times is 5 going to 20? 4. So this is 1/5 x plus 4. Okay. What is the y-intercept of the inverse? Guys, two ways to do it. Here's one way. One way is to do what? Swap x and y, get y alone. Everybody agree with that? Okay. What if I wanted to know the y-intercept of the inverse? Well, I'm going to give you guys a quick hint. The y-intercept of the inverse is what of the function? The y-intercept of the inverse is what of the function? The x-intercept. Because what happens when you take a function and create an inverse? Swap x and y, right? So the y-intercept of the inverse is the same as the x-intercept of the original function, right? Guys, how do you find an x-intercept? Yeah, to find an x-intercept, we set y equal to 0. How do I get rid of that 3/5? Good algebra lesson. How do I get rid of that 3/5? Multiply by the reciprocal. Now, why the reciprocal, guys? What am I doing to this x? Tell me, what is this 3 doing to the x? Multiplying. What's the opposite of multiplying by 3? Dividing by 3. So if I divide both sides by 3, then I would do that, right? And then what's this 5 doing to the x? Hang on, I'm going to come back. Hold on. What's the 5 doing to the x? Dividing. What's the opposite? Multiplying. So now if I multiply both sides by 5, what did I just do? I multiplied by 5 and then I divided by 3 on both sides, didn't I? John, did I answer your question? I knew I was going to say. So what happens over here? What's 3 times 5? 15. What's 5 times 3? 15. What's 15 divided by 15? 1. So that's where the x gets by itself, right? And then what's this say? This says 5 times 9 divided by 3. 5 times 9? 45 divided by 3? 15. All right. And guys, on a multiple choice question like this, do you need to do that in your head? No, you're hopefully going to just end solve that, aren't you? Yeah. Which equation represents the inverse? What am I going to do? Switch them. All right, look at our choices. Is that any of our choices? Absolutely, positively not. If you look at all your choices, what is by itself? Well, there's a y minus 2, a y minus 2, a y minus 6, a y plus 2. I want to try to get this thing alone. What can I do to get this thing alone? What's being done to this whole thing? It's being multiplied by 4, right? So what's the opposite? Dividing by 4. So I get that. Is that a choice? Not the way I wrote it, right? Guys, dividing by 4 is the same as what? What is dividing by 4? The same operation as multiplying by 1/4. Yeah, let's write that down. Dividing by 4 is the same as multiplying by 1/4. So in this case right here, guys, I can change this dividing by 4 to this. And now I have a choice that says that, right? It's choice number 1. Is that good? #26. Which of the following points lies on the graph of the inverse? Guys, this is such a cool problem. Do you recognize the way that this is written? point slope formula, right? Good review. This is good review. We got a test coming up shortly, right? Do you guys agree that the point slope formula is this? Y minus y1 equals m times x minus x1. Okay, this is going to be tough. This is going to be tough. What's the slope? 5, no doubt about it. This is the part that's going to be tough. What's the x1, y1? Because I know that I plugged a point in to get that equation. What is the x1, y1? Well, the formula is y minus y1. This says y minus 8, so what's y1? 8. Okay, if it was, now look over here, I'm supposed to do x minus x1. Well, the only way for this to have been a positive if I did x minus a negative number. So what was x1? -2. So a good way to think about it, guys, is I just took the opposite signs of what was already here. Okay, so what does that tell me? It tells me that this was a point on my original graph. So guys, if that was a point on the original function, what's a point that must have been on the inverse? 8, -2. Because what did I just do with the point? Flipped it, switched it around. I love what you're thinking, right? Because we got to think to ourselves, what happens, right? What happens if we don't know what to do, right? Here's the thing, guys. You are going to sit down at your Algebra 2 Math Regents exam, and you're going to run into some cases where you are stuck, okay? That is a definite guarantee. So I love the fact that Trinity's thinking to herself, okay, well, that's a great way to do it, but what if I don't remember that formula? Let me show you this, guys. If I go to add a graph, if I don't want to add a graph like this, if I want to add a graph as a relation, what can I do? I can change that to be a relation, right? Well, I know what this equation is, right? If I asked you guys to give me the equation of the inverse, you could do it really quickly by just doing what? Switching the x and y. So it would be what? It would be x minus 8 equals 5 times what? Plus 2? So do you guys agree that this right here is undoubtedly the equation of the inverse? Because I did what? Switch the x and the y. Okay? So now what am I going to do? All I want to know is which one of those points is on it. Well, 8, -2. 8, -2. That seems reasonable, doesn't it? In fact, if I really want to make sure, can I trace to 8 and see where I am? That worked out well, didn't it? Okay. Now, let's check the other points. What about -8? Oh, where's -8? -8 is at -5.2, so that's no good, right? That's not what we wanted. -10. -10's not at 40, right? And -2 is not at 8, right? So Trinity's question's excellent, right? What do I do, or what are some of my bailouts, right? What can I do when I don't remember the equation or the formula? And that's a great way to do it. Go ahead, Johnny. You're going to ask me a question. I didn't put the original function. I put what? I put x minus 8 equals 5 times y plus 2, right? I swapped them. Okay, ready? Which of these functions would have an inverse that is also a function? Okay, this is where I said, let's go back for a minute, because I wanted to talk about one more thing in here, right? If a function, so this is like one of those little rules that shows up every once in a while, okay? If a function has an inverse, then its function can be represented by this. Okay, we talked about that. But down here it says that a function will have an inverse that is also a function if and only if it is 1 to 1. Okay, so let's go back. Let's go back. A function would have an inverse that is a function. Oh, hang on. Would what? Would not have an inverse, right? Oh boy. All right. Would not have an inverse. So what am I looking for? I'm looking for which function is not 1 to 1. Well, guys, choice 1, y equals x. Isn't that just a positively sloped line? Okay. Do you guys agree here I could divide by 2 and get y equals 1/2 of x? And isn't that just a positively sloped line? And here I have y equals 2. Y equals 2 is a line that looks like that. What kind of a line is that? Horizontal. And y equals 5x minus 1 is a positively sloped line, right? The only one that doesn't fit is which one? Choice 3, right? And why is choice 3 not 1 to 1? Because a horizontal line doesn't pass the horizontal line test, because the horizontal line would touch the horizontal line everywhere, right? Everywhere. Good? Let's see. I want to just do this piece here, guys, because we actually have to do like a couple of things together in the next lesson, so I want to get a little bit ahead on this, okay? And that's dealing with something known as piecewise functions. You guys did this in algebra class. Piecewise functions. Let me give you a quick idea of what one of these might be. When you get insurance, anybody in here drive yet? Probably not. Let's suppose you guys get your license, like over the summer. Anybody going to turn 16 over the summer? Yeah. So maybe you get your license over the summer. Maybe you've saved up money doing side jobs. You want to buy a car. Well, if you buy a car, you have to have what? Got to have car insurance, right? Is car insurance expensive for you guys or cheap? Why? Because you're so young. Well, what happens? As you get older, it goes down a little bit, right? It goes down because what do the insurance companies assume? You're more experienced, you've become more mature, more responsible, the more cautious, right? But that happens. It goes up again when you're old. Because as you get older and older and older, what happens? You start to lose, so you lose your mind, sure. You start to lose some of your facilities, you're not as quick, you're not as sharp, right? And so maybe you're a little bit more prone to getting into an accident, right? So the way don't write this down, but the way insurance works is you have age and then you have cost. And so 16, let's say 25, 35, 45, 55, 65, 75, 85, and then there's different cost levels, right? Well, what they do is they do something like this. They're saying, okay, well, if you're 16 years old, up to like age 25, maybe it costs $1,000 every 6 months, okay? And then maybe when you get a little bit older, the cost goes down a little bit, right? And then maybe when you get a little older, the cost goes down a little bit more. But then all of a sudden, it starts to what? It starts to rise up again. This is called a step function. What a step function is, guys, is I can't write this as one single thing, okay? because this is different than this, is different than this, is different than this, is different than this, is different than this. So I have to have different pieces of the domain, hence the phrase piecewise function, okay? So Blake, here's what I got. Here I have two different pieces. And what I do is I indicate where those pieces exist on your graph, okay? So I say, ready? From -3 to 0, from -3 to 0, I'm going to use the blue function. Then from 0 to 4, I'm going to use this yellow function. Now, there's one thing I got to be really, really careful about, and that's the signs that are on these in terms of the inequalities. Because some of them include areas and some of them don't, and we'll talk about that in a minute. Okay? So here's what I want to do. At -3, guys, at -3, am I on the blue function or the yellow function? At the blue function, right? At -3, I'm on the blue function. If I take -3 and plug it into this, what do I get? -3 minus 3 is -3 minus 3 is -6. Now, one thing I want to be careful about. Is -3 a part of the domain? Listen to the question carefully. Is -3 a part of the domain? It says -3 is less than or equal to. So is it a part of the domain? So I'm going to make a little note that that's going to be a closed circle. And on my graph at -3, -6, I'm going to put a closed circle. -3, -6. All right. Then I'm going to go to -2. Is -2 on the blue or on the yellow? On the blue, because -2 is a number between -3 and 0, right? -2 minus 3 is -5. Right? At -2, I'm going to go to -5. At -1, okay, I'm going to plug -1 in. What do I get? -4. And then I go to 0. And then I go to 0. And this is where I'm going to confuse the hell out of you. So if you're not really with me right now, now's the time to get on board. Where's 0 lie? 0 is in the yellow function. Why? Because it's because it's equal to, right? And this one says what? Yeah, well, I know what you're saying, right? This 0 is included here. This 0 is not included. But let me ask you a question. Is the number just next to 0 included? It is, right? Like right next to it, right? Like right next to it. So here's the deal. 0 is going to be in this function, no doubt about it. If I plug 0 into this, what's half of 0? 0 plus 4? 4. So I know that 0, 4 is going to be something that's on my graph with a nice dark circle, no doubt about it. So I'm going to go to 0, 4. And I'm going to put a nice dark circle. But here's where I'm going to confuse you. I also want to plug 0 into this. Okay? Now, you're going to say, Picardo, hang on a minute. Don't lie to me. You can't plug 0 into that. Watch what I'm going to do. If I plug 0 into this, what do I get? -3. Where's 0, -3? It's right down here, right? Watch what I'm going to do. What did I put there? An open circle. What does that mean? It's not included. But guys, isn't everything right next to it included? So don't I have to bring my line right up to it? So close that I put an open circle there because that's where it's going, right? It's not going to get there. It's not going to get there, but that's where it's going. Is that okay? All right. What about 1? Where am I going to plug in 1? Yellow or blue? Into yellow. All right. What's half of 1? A half. Plus 4? 4.5. I'm not going to plot that point. Okay, I'm not going to plot that point because I don't like doing halves. What about 2? If I plug in 2, it's half of 2. 1 plus 4. I can plot that one. Half of 3. 1.5 plus 4. 5.5. Half of 4 plus 4. Okay, so I go to 4, 6. Is 4 part of my answer? Yeah, so I'm going to put a nice open circle or a nice closed circle on that, right? And play connect the dots. How do you guys like that? Pretty cool, right? It's kind of cool. State the range. State the range. Guys, when we talk about range, what am I talking about? I'm talking about low to high. So if I look at my graph, what is the lowest value on my graph? It's right here, correct? Okay, what is that value? That is the value -3, -6. When I talk about range, am I talking about X values or Y values? Y values, right? So it's low Y to high Y, right? So the lowest Y is -6. Am I touching that point? I am, right? So I start at -6. Okay, ready? And I go up. But hang on a minute. Do I include all the Y values on the way up? No. Isn't this where it kind of like, I kind of got like this jump in here, right? I got this gap. So my Y values go from -6 to whatever this is. What is that? That's 0, -3, right? So they go from -6 to -3. Is -3 part of the answer? No, because what's that? -3. Open circle. So what am I going to put on -3? A parenthesis. Great. Okay. Then I go up and I got nothing in here and I got nothing in here and I got nothing in here and then I hit something else. What's that value? 0, 4. So do you agree that I start hitting Y values again at 4? So I'm going to create a union that starts at 4 and goes up, goes up, goes up until I get here, which is at the point 4, 6. And that is the proper range using interval notation. Okay? Now, I want to show you guys how to put this in the calculator as a piecewise function. Okay? There are benefits and drawbacks to this. So if you think that this is the end-all, say-all, you're wrong. Okay? You're wrong. This is just going to be a guiding tool. We're going to go to add a graph. Oops, we're going to go to add a graph. When you go to add a graph, guys, it's looking for you to enter a function. In this case, it's a piecewise function, so I'm going to go into the template button. Guys, anytime I talk about the template button, I'm talking about the one next to the 9. The one that has all that stuff in it like this. Okay? Do you guys see the one that we're going to use? We're going to use this one right here. Oh, sorry, this one. How many pieces are there? 2 pieces, right? So we're going to go to this one. Okay? What that'll allow me to do is it'll allow me to put this piecewise function in. Okay? So I have x minus 3 and then I have fraction a half of x plus 4. Okay, what do you think these things are for? It's for that other piece, right? It's for that domain, right? It's telling me where to do it. So I want to do the first one from -3 less than or equal to x less than 0. Do you guys know where the less than or equal to's are? It's under the equal, right? How do I go under the equal? Control. All right. And again, guys, like the world of technology and mathematics have collided in such a way that if you can't get this into the calculator, right, you're not going to get the problem right. It's going to look exactly like what's on your paper, isn't it? Right? So you're going to utilize that. Now, here's the good news and the bad news. The good news is the following. You get the picture, right? What's the bad news? It doesn't tell you whether or not things are included or not. So what I would suggest you do is this. I would always suggest, guys, that you always go to a table that corresponds to what you're doing and look at the values. At -3, I got the right value, correct? I got a value that's what? -6. It's included, right? So what should there be? A closed circle, right? And then I move on and I get to, okay, here's where the problem lies. It lies here at what? At 0. Here it says 0 is 4. If 0 is 4, how do I know that this has to be an open circle? This is a really, really good question. This is for like my top student. My top student. I'm going to ask the question again. If the calculator says that this is 0, 4, and that that's a point, how do I know that that has to be an open circle? There's a good reason. Oh, well, you're right. You're right. I don't know if you're saying the right reason, but you're right. Why can there only be one y-intercept in a graph, in a function? Because if there was more than one, it would be 2, so it wouldn't be a function because it wouldn't pass the vertical line test, right? So if the calculator tells me there's a point at 0, 4, then I know this has to be an open circle. Otherwise, it wouldn't be a function. That cool? Right? And so this, again, it's a nice tool, but it's not the end all say all. Okay? Here's what I want to do here. Here I want to actually create the function. Okay? Here I want to actually create the function. And how many pieces are there? Three. There's 3 pieces, right? There's this yellow piece. There's this blue piece. And then there's this piece that'll be green in a second. Right? So there's your 3 pieces, okay? So I'm going to create my function with 3 pieces. And do you know what I'm going to do first, guys? I'm going to figure out the domain, okay? I want to know what this point is down here first. That's the point, -1, 2, 3, 4, 5, 6, -8, -5. And then I got this point up here, which is at -2, 4. And then I got this point here at 3, 4. And then I got this point over here at 4, 5, at 6, -2. Okay, ready? Again, this is the point where I lose somebody if you're not really with me. Okay? Look at the x values, because again, when I write this, guys, I write this as function, comma, domain. Okay? So domain refers to which values, x's or y's? Okay, so x's. So if I look at the yellow, where does the x value of the yellow begin? -8. And where does it go? To -2. So the first rule is going to start at -8 and end at 2. -2. Gavin, notice what I did here. I included -8, right? Because I said less than or equal to. I also included -2. Where's the blue start? At -2, right? Where's the blue end? At 3. So watch what I'm going to do. I'm going to start at -2. I'm going to end at 3. Guys, Calissa, here I included the -2, right? Because I said what? Less than or equal to. Here I did not include it, because if I included it here, I can't include it there, otherwise it wouldn't be a function. Now, the correct question is, well, why did you include it here and not here? And the correct answer is, you could have done it either way. So I could have done this. I could have done it either way, okay? Where's the green begin? Green begins at 3. Now hang on a minute. Did I include 3 here? No, because it says what? Just less than. So if I don't include it here, what do I need to do here? I need to include it. And where does it go? It goes till I get to 6. All right, and so that represents the domains, okay? When we come back next class, what we'll do is we will find the actual functions that create each of these.